This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. Okay, so we go now to sample problem applying our K-map. Now, what we have here is a sample problem which is the same as the sample problem that we have in our Boolean or deriving Boolean algebra equation. This is just the same example. Okay? Now, this time, I added the word simplified so that what we are required here is a simplified logical circuit. So, the equation that we derived during our previous discussion in deriving Boolean algebra equation was not yet a simplified equation. Okay? So, using K-map now, we will be able to simplify that particular equation. Okay? So, again, the first step is to make a table. Okay? So, we call it the truth table. Again, we have 3 switches. Okay? So, the switches are represented by, again, A, B, and C. And the output is represented by R, meaning relay. Okay. So what are the combinational values of A, B, C again? You have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the combinational values of inputs A, B, and C. These are the switches, no? A, B, and C. Then, how do we obtain the output R? So again, the problem says it will activate a relay whenever either only one or all of the 3 switches are closed. When you say closed, that means that one. Okay? Only one here. Then here one, or all of the 3 switches are closed. One. So that will be your output R. So the rest will be 0. Okay? So we make a K-map representation. Okay? Now, if we will use the min term, okay? So what will be our min term equivalent here? So we know that the decimal values of these combinational values are 0, 1, 2, 3, 4, 5, 6, and 7. So what will be our min term? So F or R as a function of A, B, and C is equal to summation of min terms. Okay, so that is the R with a value of 1. So you have 1 here, then 2, then 4, then 7. Okay, so that will be our min terms. Okay, now how do we locate this decimal equivalent in our map? So we say this is 0, 0, 0, that is 0 in decimal number. You have 0, 0, 1, that is 1 in decimal number. Then you have 0, 1, 0, that is 2. And this one here, 0, 1, 1, this is 3. And then 1, 0, 0, this is 4 here. 1, 0, 1, that is 5. So this is 1, 1, 0 is 6. And this one here is 1, 1, 1, which is 7. Okay? Then we locate the value of your midterms, 1, 2, 4, and 7. So you have 1, 2, 4, and 7. So if you notice that there is no adjacent cells here, there's no 4 adjacent cells, there's no 2 adjacent cells. In other words, these are individually grouped, no? Because the cells are, or the cells have no adjacent. Okay? So in other words, this one here, we know that this is under A bar, and this is under A, this is under B, B bar, B bar, C, C bar. So what will be our equation? R as a function of A, B, and C is equal to, so this one here is what? The intersection of this is under A bar, then it's still under B, and C bar. Okay? And this one here is under A, under B bar, and under C bar. This one here will be what? This is under A bar, this is under B bar, and C. Okay? Then this one here will be under A, B, C. That's the equation or the variable terms. So, our equation will be R as a function of A, B, C is equal to A bar, B, C bar, plus A, B bar, C bar, plus A, B, C, plus A bar, B bar, C. So if you notice that the equation that we derived this time is the same as the equation that we have last discussion. Okay? So in other words, the equation that we derived that time was already a simplified logical equation. So, since they are the same. Why? Because there were no adjacent cells here present in your K-map. Okay? So, what I'm saying is that the equation that we derived last time during our discussion on Boolean algebra equation or deriving Boolean algebra equation is the same as the equation that we derived here. So that means that they are just the same, or meaning to say that this one here is already a simplified equation. Okay? So how do we represent that in our circuit? Okay? So we have how many AND gates? 1, 2, 3, 4 AND gates. So we will have the same logical representation that we have last time, no? Okay, so you have A bar, then you have B, and then you have C bar. Okay, then you have A, B bar, and then C bar. Then you have A, B, C, then you have A bar, B bar, C. You have A, B, C. And these 4 AND gates are being added together or ORed together using an OR gate. So this will be our R. So if we want to perform this through our experiment, this will be your circuit, no? So you have 3 lines. Okay, so let's say, for example, this is switch A. This is your A, and this is your B, and this is your C. Okay, so all A will be connected in this line here. So this one A connect here, and this one A, A, A. Okay, then B, all of the variables B here will have to be connected in this area. So that is B, this one, then C here, okay, so that will be our connection. So this is switches A, B, and C. So if switches A, B, and C are closed, that means that this will be connected here. So that means that A, B, and C are 1. So if A, B, and C are 1, then that means that your relay here will turn on, okay, and therefore R is equivalent to 1. We have now a sample problem, and this time it's about alarm system, no? To be specific, fire alarm system. Okay, so the problem states that there are 4 temperature sensors. Okay, so these are our inputs, 4 temperature sensors in the system, and each sensors have its own temperature requirement. Okay. Now, the system operates as follows. If one or any 2 of the input is on, nothing happens. Then, second condition, if any of the 3 inputs are on, then the alarm system sounds and the fire department is notified. Okay? So let us interpret these conditions here through our truth table. So what we have here is a 4 variable inputs represented by A, B, C, and D. And these are our 4 temperature sensors. Okay? With each temperature, or with each sensors here has its own temperature requirements. Okay. So based on our requirement, if one or any 2 of the input is on, nothing happens. So this one here, of course, basically this is 0, 1, so it is 0, 1, 0, 2, 0, 1, 0. We have 2 ones here. Again, this is 0. This is 1 by the way, 0 by the way. And then you have here 1, 1. This is 0. Okay. And this one here, you have 0 and 0. Then what else? This one here is still 0. Okay. Now, the second requirement is that if any of the 3 inputs are on, then the alarm siren sounds and the fire department is notified. So, if any of the 3 of the inputs are on, then the output is 1, no? So this one here, this is 0, and this one here, you have 3, 1, 2, 3 inputs are on, and 1, 2, 3 inputs are on, 1, 2, 3 inputs are on, with any of the 3 inputs are on. So this one here still be equal to 1. Okay, so this will be our truth table. So again, if any 1 or any 2 of the inputs is on, nothing happens, no? So, kung isa lang or duha, nothing happens. Meaning to say, the output is 0. But, if any of the 3 inputs are on, any of the 3, then the output is 1. No? So, you have here, 3 inputs here are 1. This one here, 3 inputs are 1. You have 3 inputs are 1. 3 inputs are 1. And for any of the 3 inputs are on, so the output will still be equal to 1. Okay? So that will be our truth table representation of this particular requirement. Okay? Now, let us obtain the logical circuit equivalent using our K-map. Okay? So let's say we use first the min term. Okay, so it is represented by summation of small letter n. So your output there is S as a function of sensors A, B, C, and D is equal to summation of min terms. You have what? This is, oh, by the way, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so what are the min terms? 7, you have 11, then you have 13, 14, and 15. So that will be your min term. So what will be our map representation? So we draw a map. Okay, so 4 variable map. This is A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Again, the placement of your decimal numbers are, this is 0, 1, down, 2, 3, 4, 5, down, 6, 7, side, 8, 9, down, 10, 11, 12, 13, down, 14, and 15. That will be our map representation. Then we locate our min terms into our map. So you have 7. So since this is min term, sum of product expression, we put a 1 in the cell. Then you have 11, 13, 14, and 15. We know that this area here belongs to A bar. This is A. This is B. B bar. B bar. C. C bar. D. D bar. And D bar. Okay? So what will be our grouping? So we find 8 adjacent cells. I believe na wala tayo 8 adjacent cells here. So we go to 4 adjacent cells. Wala po tayo 4 adjacent cells. So we go down to 2 adjacent cells. So we have here, this one, this 13 and 15 cells are adjacent. So we group them as 1. Okay. Now again, 15 here and 11 are adjacent, and this 11 here is not yet grouped. So we use cell 15 to group them together. And then if you notice that 14 here is also adjacent to 15. Even if 15 have been used in the other grouping, we can still use 15 for the grouping in that manner. Okay? So we make use of 15 to group 14. And then we have 7 is still adjacent to 15 for as long as the cell that you are going to group to another cell is not yet grouped, then we can make use of this cell 15 to be used for another grouping. Okay? That is how we group our cells. So, in this case, what will be our equation? This one here belongs to A, then it belongs to B, and it belongs to D. Okay? And then this one here belongs to, again, A, belongs to C, and belongs to D. Okay? And then, this one here belongs to A, belongs to B, and it belongs to C. Okay? And then the last one, this one here, this belongs to what? B, belongs to C, and D. So that will be our variable terms, no? So the equation, therefore, using the mean term or SOP will be S as a function of A, B, C, D is equal to A, B, D plus A, C, D plus A, B, C plus B, C, D. So that will be our logical equation. And if you want to draw the simplified logical circuit, we need 1, 2, 3, 4 AND gates. So you have 1, 2, 3, 4. Okay? So you have A, B, D, A, C, D, A, B, C, and B, C, D. Okay? And all of these are being added together or being ORed using an OR gate. So this is your S as a function of A, B, C, D. So this is A, B, D, A, C, D, A, B, C, and B, C, and D. So this will be your logical circuit equivalent. Now, if you want to perform this in experiments, all A's here are interconnected, all B's are interconnected, all C's are interconnected, and all D's are interconnected. Okay? So this is our mean term. So how about if we will obtain the max term equivalent, or we call it the sum of, or the product of sum expression. No? Okay? So what will be our max term equivalent? Okay? So S as a function of A, B, C, D is equal to pi capital M. Okay? And what are the max terms? These are the cells which are vacant in this particular map. Okay? So what cells are vacant? You have 0, 1, 2, 3, 4, 5, 8, 9, 10, and 12. That will be your max term. So again, you have 0, 1, 2, 3, and then 4, 5, then 8, 9, 10, 8, 9, 10, and then 12. Okay? That is our max term, no? Vacant cells. So what will be our K-map representation? So we draw again a map. With 16 cells. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Again, the same ang locations among numberings. You have 0, 1, 2, 3, 4, 5, 6, 7. Then here 8, 9, 10, 11, 12, 13, 14, and 15. Then we locate the max terms. By the way, we forgot to place or include the 6, no? So we just put it here. After 5 is 6. So we include 6 here. You have 0. Okay? Then we all know that this one here belongs to A in our max term. So opposite ani ato ang min term. So this time this is A and this one here is A bar. This one here, opposite here, this is B. So therefore this one here is B bar and this is B and B. And this one here it is C. So opposite C complement. And this one here is C, and this one here, this particular area will be D bar, D, and D. Okay? So we group them as A's, no? So we maximize first the grouping. 8, 4, 2, 1. So we try to find 8 adjacent cells. So naa ba siya? I think wala siya 8 adjacent cells, no? So we go to 4 adjacent cells. Now by 4 adjacent cells, naa, no? So this one, this is 4 adjacent cells in line. Okay? Then we have this one here. These two adjacent cells are also adjacent to these 2 cells here. So we group them. We have 4 adjacent cells. Okay? And then, if you notice that we have 2 adjacent cells here, which are adjacent to this one here. So, we group them as 1 again. 4 adjacent cells. Okay? Then, naa po ba yung 4 ka adjacent cells? Naa pa, no? This one is not yet grouped. And this is adjacent to this cell and this cell. So we have this one, like that, and this one here. Okay? So, unsa pa yung bilin nga wala ma-group? This one, wala pa siya ma-group. Okay? And this one here is adjacent to these 3 other cells. Okay? So, this one here, this one, and this one. Okay? That is 4 adjacent cells. What is left is cell number 9. Now, cell number 9 is still adjacent with this one here and this one. No? So, 9 and 8 are adjacent, and 9 and 8 are also adjacent to 0 and 1. So, we have this one and this one. Okay? Can you follow? So I hope that you can follow so that you will be able to determine the simplified logical circuit. So everything here are already grouped. All cells are already grouped, so no need to group again the cells. So let's find the logical equation. Okay, so for this one, the cells in the corner at 1. So this is under what? B. Remember, this is product of sum expression. So plus. B plus D. Okay? Then, this one here, the longer or the line, this group, this one, this is under C plus D. Okay? So, this one, the square, what will be the equation or the variable terms? This is under C plus under what? A. A, no? It's A, then C. So, A plus C. Okay? Then, what else? So, this one is done. How about this one? That is this group here and this group. So, this is under B and at the same time under C. No? This is B, then C. This one. Okay? Then, this one. The line on the side. So, this is under A plus under B. Okay? And then, the last one will be this one. That is this one here and this one. So, that is under, this is under A plus side, this one. That is under D. Okay? So, wala na ba? So, how many groups? You have 1, 2, 3, 4, 5. So, you have 5. So, 1, 2, 3, 4, 5, 6. No? So, you have, again, let's review. This is 1, then 2, okay, then 3, okay, then 4, okay, then 5, this one, and then 6. Okay, so we have 6 groups. So the final equation will be S as a function of A, B, C, D is equal to, remove the pi m symbol, just write immediately the equation. So you have B plus D times C plus D times A plus C times B plus C times A plus B times A plus D. That will be our simplified logical equation. Then we draw the simplified logical circuit equivalent. So how many OR gates? 1, 2, 3, 4, 5, 6. 6 OR gates. 1, 2, 3, 4, 5, 6. Okay? 1, 2, 3, 4, 5, 6. And then they are being multiplied together. So we use AND gate. So we have B, D. Then you have C, D. Then A, C. Then B, C. Then A, B. Then A, D. Okay? Then, we multiply them together using AND gate. This will be your S as a function of A, B, C, and D. Now, you might ask, what's the difference between using the min term and the max term? Actually, it would depend on you, no? So, for example, if you buy an IC, no, mag-assemble na ka, fire alarm system. Then, when you go to an electronic shop, walay available nga AND gates. Or gamay rang AND gates ang available OR gate. So, instead of using the sum of product expression, we use the max term or the product of sum expression. Kaya daghan man available nga OR gate. So, kani ato ang gamiton. Pero, if you go to electronic center, and then mas daghan ang available nga AND gate, then we will use the min term or the sum of product expression. Now, the output will provide or will produce the same output even if you use the min term or the max term. In other words, this equation here is the same as this equation here. But this one here is in the sum or the product of sum expression method, or yes, in the sum of the product of sum expression method, and this one here is in the sum of product expression method. Okay, so that's it for our sample problem in K-Math.